Hey guys, Mr. Cole here, and this will be our first lesson of online learning. And for the most part in earth science, things are going to stay pretty much the same. You're going to have packets, which is where I'm going to do the new lessons. You'll have think and writes, which is where you guys will activate your thinking about the topic. And on your copy of the packet, you'll be able to write your answer for the think and write right in there. So make sure you type in your think and write answers as we go. Okay, so for today's lesson, it starts with a story. And the story is kind of a sad story, so get ready. So this takes us back to 1945, and there were these kids in Oregon. They were playing tag in the woods, and they found this thing, and it was hanging from a tree. They had no idea what it was. They were pulling at it and throwing it around a little bit, tossing some of the bags around to each other, and they just didn't get what it was. They were really curious about it. So again, they were in the woods playing tag, and so they started dragging it out of the woods. Like it was like six kids, and they were all pulling on this thing, trying to pull it out of the woods to show their parents what it was. As they were doing this, it bumped into a rock, it exploded, and it killed all six kids. It was a national tragedy. Their parents were devastated. The whole community was perplexed. They had no idea what happened until the FBI got involved, and the FBI had some more information to provide, which was that the Japanese during World War II had created these crazy balloon bombs. So these huge helium-filled balloons with bombs attached to the bottom of them to send over to the United States to attack us. And it wasn't very effective. The only people that died were those six kids, but basically it was this terrorist plot to try to scare us into thinking that at any second they could attack us with these balloon bombs. Now, the reason that we're talking about it in earth science is that although it was like a really sad, horrible thing, it was a pretty smart way to use earth science at a time of war. What the Japanese knew was that there were these things called jet streams, which is a whole area of wind that travels in the same direction. They're called jet streams or wind belts. And if you could send a balloon up in the air high enough, this wind belt would carry the bomb towards the east. Because, and I'll highlight the one that they were using, all the wind travels in the same direction. So from Japan to the United States, it was pretty much a straight shot. If they picked up this jet stream with their bomb, it was going to travel to us, hopefully land, in their opinion, and attack us. So that's a wind belt, and that's what we're talking about today. Okay, so taking a look at some of this vocabulary today, we got wind belt, which we just talked about, a zone where all the winds blow in the same direction. An example that we mentioned was the jet stream, which carries all the weather from the west coast to the east coast. So that means that most of our weather comes from west of us. My mom lives in Ohio. If she's having a big storm in Ohio, she sometimes calls me up and says, hey, get ready, in a couple days you guys are going to have this major snowstorm or major thunderstorm, because our weather travels from the west to the east. Same way that the bombs traveled from the west in Japan to the east, our weather gets pushed by the jet stream from the west to the east. Now, most of the work today is going to be from the image below, which is page 14 of the reference table, but I gave it to you in the notes. And the jet stream that we're talking about was called the southwest winds. So that's the jet stream right there on the map. Okay, so we also have moisture belts. Moisture belts are similar to wind belts. It's an area that all has the same moisture. So you can have wet moisture belts and dry moisture belts. The wet moisture belts are places where there's a lot of moisture, and the dry moisture belts are places where there's not a lot of moisture. As it turns out, all the deserts in the world are located on the same latitudes. You got 30 degrees north, right about there. Change the color. And 30 degrees south. So there's areas on the earth that have all the same type of moisture, just like there's areas that have all the same type of wind. Okay, so now I'm going to annotate this diagram so that you guys can better understand it. Again, most of the work today is going to be from this diagram. So we talked about the wind belts. Those are areas that have the same wind direction, and the southwest winds is our jet stream right there. You got these southeast winds, northwest winds, right at the top, southeast and northeast. Okay, so those are the wind belts. They show how the wind moves on the Earth, and they're curved a little bit because the Coriolis effect, as we learned about previously, makes them curve to the side. That's because the Earth's rotating, they curve. And they're named from the direction that the wind comes from. So the southwest winds, the wind's coming from the southwest, not towards the southwest. Okay? Now, we also have these moisture belts, which are really important. I'm going to do the wet moisture belts in blue. And they're here, 60 degrees south, 0 degrees, and 60 degrees north. Now, what defines or what makes these wet moisture belts is the fact that the air is rising. So these arrows going up show that in these places, because of evaporation, the air is rising. Now we know from our previous unit that rising air forms clouds. So if the air is rising and clouds are forming, then those areas are wet because clouds bring moisture. So there's a lot of rain in those areas. The rainforests of the world are located in wet moisture zones, like at zero, like near the equator, for example. The dry moisture belts are because of the opposite reason. Dry moisture belts happen in areas where the air is sinking. So I'll annotate those areas as well. The arrows are going towards the Earth's surface here, which shows that the air is sinking. And because the air is sinking in those places, there's no clouds forming, because sinking air is high pressure, and sinking air brings no clouds. Okay, so you have your wet moisture belts at 0 degrees and 60 south and 60 north. You got your dry moisture belts at 30 degrees north, 30 degrees south, and then also at the north and south poles. And it's all about whether the air is sinking for dry or rising for wet. I can add these rising arrows here. Okay. And there you go. You guys can watch the video as many times as you need. You have a copy of the packet in Google Classroom, as well as the reference table and whatever other materials I was using as well. Okay? Really hope you guys are staying safe out there. Be well, and I'll talk to you soon.